In 1965, the Soviet Union faced chaos. Atmospheric patterns defied central planning. The vast territory required precision. Stalin had banned cybernetics before. He called it a bourgeois pseudoscience. By 1960, the ideology shifted. Nikita Khrushchev embraced new automation. Scientists founded the GIDRA epicentre in Moscow. They needed a unified weather grid. This grid served the military first. Agriculture also demanded better seasonal data. Traditional synoptic charts were too slow. Human error ruined many forecasts. Computers offered a technical solution. The state funded massive research centers. Cybernetics became the new socialist tool. Promised total control over nature. Modernity required advanced mathematical logic. The 1965 project was ambitious. It integrated thousands of weather stations. Teletype machines connected the remote outposts. Data converged at the central hub. This was the cybernetic thaw. Engineers designed complex feedback loops. They modeled the entire Earth's crust. Every air current mattered now. Politics drove the scientific funding. Space race technologies influenced the design. Cold War tensions demanded weather accuracy. Missile trajectories relied on wind data. The system had to be flawless. This was the genesis of automation. Scientists mapped the tropospheric layers. They installed sensors in the Arctic. Information flowed through radio wavelengths. Centralized power required centralized data flow. No village was too remote now. The plan covered 11 time zones. It was a digital iron curtain. Weather was a matter of state. Survival depended on the next harvest. Failure meant hunger for the masses. Science provided the only viable shield. The 1965 era started this revolution. The party demanded 5-year weather plans. Efficiency was the new socialist metric. Every station sent data every hour. The clock started ticking in 1965. This was the birth of GIDRA. It changed global meteorology forever. The silence of the Moscow morning in 1965 was not a void, but a preparation. Every slab of brutalist concrete at the Hydrometeorological Centre stood as a testament to the Soviet ambition to conquer the unpredictable. These antennas were not merely steel structures. They were the collective ears of the state, tuned to the frequency of the atmosphere. Here, the gray sky was no longer a mystery but a massive data set waiting to be harvested. Every rotation of the parabolic dishes synchronized with the pulse of the city, marking the beginning of the great numerical experiment that would define the cybernetic era. It was the physical birth of a dream where nature itself would be digitized. Hardware defined the Soviet 1960s era. The BSM-6 was the crowning jewel. It used high-speed transistor logic gates. Sergei Lebedev led the design team. The machine occupied huge cooled rooms. Ferrite core memory stored vital data. Thousands of copper wires carried signals. The clock speed reached 10 megahertz, processed 1 million operations daily. This was a global performance record. Water cooling kept the cabinet stable. Power consumption remained extremely high. Cables snaked across the concrete floors. Technicians monitored the glowing vacuum tubes. Hybrid circuits bridged 2 different eras. Magnetic tapes recorded the atmospheric flux. Huge drums spun at high RPMs. Precision engineering was the only priority. Each rack weighed several hundred kilograms. The architecture was modular and scalable. Input came from paper punch cards. Punch tape provided backup data streams. Air conditioning units hummed loudly nearby. The noise was constant and deafening. Sensors detected temperature shifts in racks. Maintenance crews worked in 3 shifts. Every component was made in Russia. They avoided Western integrated circuit designs. Reliability was a core military requirement. This machine calculated global pressure fields. It transformed raw numbers into maps. The physical footprint was truly massive. It required 200 kilowatts of power. Voltage regulators prevented any sudden surges. The cooling system used refined oil. Logic gates flickered in the dark. Rows of cabinets lined the hall. Each unit handled specific matrix tasks. The memory capacity was 32 kilowatts. This seems small by today's standards. In 1965, it was a miracle. The system used floating-point math units. This increased the precision of results. Every solder joint was checked twice. Metal casings protected the delicate parts. This was the anatomy of power. Technicians used specialized oscilloscopes for testing. Data integrity was the highest command. The cooling pipes hummed under pressure. The mainframe lived in sterile silence. It was a mechanical titan. Entering the halls of the BSM-6 felt like stepping into the brain of a sleeping titan. This was the anatomy of the system, a labyrinth of 10 million logic gates and copper wires. The electronic hum was a continuous choir of mathematical certainty. We see the ferrite rings, microscopic yet holding the weight of entire oceans. This hardware did not just process numbers. It breathed the logic of a new world. Every glowing tube and spinning magnetic platter represented a triumph over the analog chaos of the past. It was here that the raw elements of the Russian winter were finally tamed by the cold logic of silicon and steel, turning frost into binary code. Algorithms turned noise into useful signal. Lev Gondin pioneered the objective analysis. He used statistical interpolation for grids. The system solved primitive fluid equations. Dynamics followed the Navier-Stokes principles. Computers modeled the atmosphere as layers. Each layer represented a pressure level. The 500 millibar height was critical. Math replaced the old hand-drawn maps. Finite difference methods divided the sky. A hexagonal grid covered the USSR. This prevented errors near the poles. Logic gates processed the barotropic models. Later models included baroclinic vertical flux. Heat exchange variables entered the code. Friction against the terrain was calculated. The code was written in autocode. Optimization was a mathematical necessity here. Every byte of memory was precious. Programmers used clever binary arithmetic tricks. They accounted for the Coriolis force. Solar radiation values updated every hour. Cloud cover algorithms remained very simple. Moisture levels impacted the local density. The system predicted cyclones 3 days ahead. Feedback loops corrected the initial bias. Errors were filtered using Gaussian curves. This was the logic of control. No human intuition was allowed now. Pure math governed the Soviet sky. Linear equations described the wind vectors. Divergence and vorticity were calculated constantly. The system produced 24-hour forecast maps. These maps guided the Aeroflot flights. Every calculation followed a strict sequence. The logic was cold and absolute. It ignored the chaos of reality. Statistical weights adjusted the input data. Missing station values were estimated logically. The software ran on machine code. It was a masterpiece of efficiency. The logic never slept or tired. The algorithm dominated the central processor. It was the heart of GIDRA. Information transformed into digital prophecies. Thousands of kilometers away, the connection remains thin but unbreakable. Out in the Siberian tundra, the remote stations stand as lonely outposts of the mind. The data journey is a brutal one, traveling through frost-covered wires and vibrating relay towers. It is a transformation. A single degree of frost becomes a punched hole in a paper tape, then a binary pulse traveling across a continent. This is the nervous system of GIDRA, reaching into the white void to pull back truth. The mechanical clicking of the teletype is the only sound against the howling wind, bridging the isolation of the forest to the strategic core of Moscow with relentless mechanical precision. Limits eventually slowed the cybernetic dream. Data transmission remained a major bottleneck. Teletype lines used slow baud rates. Remote stations often lost their signals. The lack of disk storage hurt. Magnetic tapes were too slow for queries. Processing took several hours every night. Real-time updates were simply not possible. The system struggled with local terrain. Mountains caused unpredictable turbulence in models. The 1965 architecture had clear bounds, could not model small storms. Only large-scale systems were visible. Political pressure demanded impossible accuracy levels. Engineers faced severe resource shortages often. High-quality transistors were rare in 1967. Some components failed due to heat. The power grid was often unstable. This caused data corruption during runs. Foreign computers were still more advanced. The Soviet gap began to widen. Experts warned about the coming stagnation. The GIDRA project reached its peak, could not scale any further. Costs exceeded the planned state budget. New leadership shifted the national priorities. Space exploration took most of the funding. The weather system entered maintenance mode. It functioned until the early 70s. Then, the next generation took over. This was the end of 1965. The reports showed a 70% accuracy. This was high for that era. But the world wanted more precision. The hardware grew old and brittle. Technicians began to salvage the parts. The dream of total control faded. The logic met its physical limit. It stopped. The machines were finally decommissioned. The result was never just a map. It was a prophecy written in green light. On the CRT screens of the analysts, the chaotic dance of the atmosphere became a series of calculated vectors. This was the summit of the 1965 vision, the moment when the machine and the map became one. Even as the hardware aged and the lights began to flicker, the mathematical legacy was secured. The cold stars of the Moscow night now look down on a world that has mastered the grid. The dream of GIDRA did not die with the old racks. It evolved into the digital heartbeat of the modern age, a silent master of the invisible air, proving that math is the only eternal language. The 1965 system left a legacy. It proved that automation was possible. The Gondin method is still used. Modern models rely on those equations. The Soviet experiment was a milestone. It integrated an entire continent's data. Thousands of engineers learned new skills. They built the foundation of meteorology. Today, we use supercomputers for this. But the 1965 logic remains valid. It was a feat of willpower. Cold War science pushed the boundaries. The BSM-6 became a legend. It served the Union for years. Data flow became the new currency. The system showed the power of math. It was a cybernetic triumph. Humans moved away from the charts. We entered the age of silicon. This history is worth remembering now. It shaped the global weather net. The 1965 project was a bridge. It linked the past and future. We still look at those maps. Technology evolves, but the goal stays. We want to know the tomorrow. The Soviet machines gave the answer. They calculated the wind and rain. It was a cold, digital prophecy. The 1965 era defined our world. The logic lives on today.